What is thin layer chromatography best used for separating? So chromatography is a separation technique, and in TLC we have mobile phase and stationary phase, and the molecules have a different affinity or different attraction towards mobile phase and stationary phase. And the basic principle behind this technique is molecules that have a different polarity, hence they will have a different attraction towards mobile phase and stationary phase. Hence the correct answer should be A. A simple recall question, no difficulty in this question. Ice containing only the isotopes H2 sinks and does not melt when dropped into ordinary distilled water maintained at 3 degrees Celsius. Isotope H2, we know hydrogen has 3 isotopes, H1, H2 and H3. Isotope H2 is given here, and sinks means is more dense than H1, and does not melt means it has a high melting point. Go through these statements. A. The isotope H2 has a higher natural abundance. Now is wrong. If we look at the AR of hydrogen in the periodic table, which is 1.01, if H2 is more abundant, has a higher abundance, then the AR should be close towards 2, not 1. Number 2, H2 has a higher melting point than normalized. That seems correct because it doesn't melt when dropped into ordinary water. But let's read C. H2O has a lower density than normalized cold water. No, it has a higher density, that's why it sinks. And D, H2O deuterium has different chemical properties from normal water, which is wrong because they are isotopes. Isotopes have a similar chemical properties because they have the same electron configuration. Hence the correct answer is B. The table lists successive ionization energies of an element Z, which is the formula of stable oxides of the element Z. We have been given successive ionization energies. So if you look, second ionization energy is slightly bigger than the first ionization energy, and similarly third ionization energy is bigger than the second ionization energy. And when we compare third to fourth ionization energy, so there is a big jump. So the fourth ionization energy is a lot higher than the third ionization energy. The reason why we're removing electron from the next shell, which is closer to the nucleus, so that suggests the given element Z has 3 electrons in its outer shell and is in group 13. So the charge on Z will be 3 plus, and oxygen is in group 16, so charge will be 2 minus. Hence the correct formula will be Z2O3, and the correct option is C. The container holds 30 grams of argon and 60 grams of neon. What is the ratio of number of atoms of argon to the number of atoms of neon in the container? So what we need to do, we need to convert mass into moles first. So mole is equal to mass over molar mass. So the mass of argon is 30, and molar mass of argon, if I look in the periodic table, is 39.95. 39.95. If I solve this, that will give me almost 0.751 mole. Okay, so these are the moles of argon. Let's work with the moles of neon. So 60 divided by the molar mass of neon is 20.18. And if I solve this, that will give me 2.973 mole. Okay, the ratio of number of atoms of argon to number of atoms of neon, 0.751 with 2.973, and that will give me almost 0.25. Hence the correct answer is A. So the key thing here is we need to convert these masses into moles first, because 1 mole of any substance contains the same number of atoms, Avogadro constant. A gas storage tank of fixed volume V contains n molecules of an ideal gas at 300 Kelvin. With a pressure of 40 kilopascal, n by 4 molecules are removed, and the temperature is changed to 450 Kelvin. What is the new pressure of the gas in kilopascal? N by 4 molecules are removed. That means we have 3 by 4 molecules left behind. So let's work out how much pressure they will exert at 300 Kelvin. So if we multiply 3 by 4 with 40, they will exert 30 kilopascal pressure at 300 Kelvin. Now, what pressure they will exert at 450? Temperature has changed by a factor of 1.5. If I multiply 30 kilopascal with 1.5, that will give me the new pressure, and that is 45 kilopascal. There is another way to answer this question, so you can use PV and RT, but this is a lot easier than that. So the correct answer is C. What is the formula of the compound formed between magnesium ions and hydrogen carbonate ions? So magnesium is in group 2, and the charge on magnesium is 2+, and hydrogen carbonate is HCO3-. So there will be no overall charge. That means we need another HCO3- to have no overall charge. The correct answer is B, MgHCO3 twice. In which group of ions and molecules are electrons delocalized in all species? In all species, ions and molecules, electrons are delocalized. Key things. In A, we have ethanoic acid. So in ethanoic acid, they are all localized electron. If we display the formula of ethanoic acid, you can see all these electrons, they are localized, hence A is not the option. Although in O3 there are delocalized electron, and in C60 as well, but in ethanoic acid, all the bonds, all the electrons, are localized. Look at B now. So we have ethanoate, display that, CH3, C double bond O, and then we'll have O, and we'll have 3 lone pairs and negative charge. So there are more than one possible position for the double bond. So ethanoate ions, yes, electrons, they are delocalized. But let's look at NO2-. So nitrogen has 5 electrons, each oxygen has 6 plus 6 plus 1 extra, so I will have 6, 12, 17, 18 divided by 2, so we'll have a 9 pairs. Nitrogen is the central atom. If we throw oxygen around, connect them with the bond, distribute the remaining until they will have 8. So I have utilized 4 and 4, 8 pairs, so the 9th pair will come in the nitrogen. Nitrogen is not following the octet rule at the moment, so I will shift 1 pair between nitrogen and oxygen, so we will have N, O, O, 1 pair, double bond O. And now we can see there are more than one possible position for the double bond. So there is a resonance and delocalization. In graphite, each carbon connected to 3 other carbons, and the 4th electron is delocalized to carry the charge around. Hence, correct answer is B. But let's have a quick look on C. So we have ethine localized, and in D we have ethene, all delocalized electrons. So B is the correct answer. What is the molecular geometry of central atom in SF4Cl2? So let's draw the Lewis structure first. So sulfur has 6 valence electron, plus each fluorine has 7 times 4, plus each chlorine has 7 times 2. So if we add them together, I will have 48 electrons. If I divide that with 2, I will have 24 pairs of electrons. Sulfur is the central atom, so let's put F around 3 and 4 F around, and Cl and that Cl. connect them with a bond, and distribute the remaining on the outer until they will have 8, 4, 6, 8, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, and 8. So let's count if we have used 24 pairs. 4, 8, 12, 16, 20, 24. So we have utilized all 24 pairs. So if you look around the central atom, there are 6 electron domains, and all of them, they are bonded pair. Hence, the electron domain geometry should be octahedral, and the molecular geometry should be octahedral as well, because we don't have any lone pair. Hence, D is the correct answer. Which is the preferred Lewis structure of nitrous oxide N2O as deduced by the formal charges? So let's assign the formal charges. So in option A, nitrogen on the left has 2, 4, 5, and 6 electron, hence it has a charge of -1, formal charge of -1, because it has 1 extra electron. And the nitrogen in the middle has 1, 2, 3, and 4, so hence this has a formal charge of +1, and oxygen has a formal charge of, so it has 2, 4, 5, and 6 electrons, so formal charge of 0. Option B, nitrogen on the left has 2, 3, 4, 5 electrons, so formal charge 0. The nitrogen in the middle, 1, 2, 3, and 4, and hence a formal charge of +1. And oxygen has 2, 4, 6, and 1, 7 electron, and hence a formal charge of -1. If I move to option C, so nitrogen on the left has 2, 4, 6, and 1, 7 electron, hence formal charge of -2. Nitrogen in the middle has 1, 2, 3, and 4 electron, hence a formal charge of +1. And oxygen has a formal charge of, it has total 2, 3, 4, and 5 electron, so hence a formal charge of +1. In option D, nitrogen on the left has 2, 4, 5, and 6 electron, hence it has a formal charge of -1. And oxygen in the middle now, 1, 2, 3, 4 electron, hence a formal charge of +2. And nitrogen on the right has 2, 4, 5, and 6 electron, hence it has a formal charge of -1. Let's go through the options now. So B seems to be correct answer because the formal charge is close to 0, and although we have to assign +1 and -1 formal charge there, whenever we have to assign a negative charge, we assign it to the most electronegative element, most electronegative atom, which is oxygen there, and hence the correct answer is B. Which pair of statements about electrons in this molecule is correct? Number of non-bonding pairs of electrons. So number of non-bonding pairs of electrons. So let's work out that first. C, carbon, nitrogen, oxygen, and fluorine, they follow the octet rule. The oxygen which is attached to hydrogen hydroxy, that has 2 lone pairs. Okay, so 2, 4, 6, and 8. And oxygen which has a double bond, that has 2 lone pairs as well. Okay. And the nitrogen has a 1 lone pair because it has 3 bonds there, so 2, 4, 6, and 8. So if I count, we have 1, 2, 3, 4, and 5 pairs of non-bonding electrons. The correct answer can be C or D. So we can get rid of A and B. So that leaves us between C and D. Let's go to the second part of the question. So number of electrons in the pi bonds. So we have a benzene ring. In that benzene ring, we have 3 pi bonds. Means we will have 6 electrons there. And we have another pi bond between carbon and oxygen. So 1 pi bond. So total we have 4 pi bonds, and a pair of electrons is required to form the bonds. So number of electrons in the pi bonds will be 8. Hence the correct answer is D.